Now, we have to know the convenient rays for the construction of image by ray diagrams. Now, children, you have to learn these laws. This side I am drawing the ray diagrams for concave mirror, and parallelly this side I am drawing the ray diagrams for convex mirror. So let me draw my mirrors first. This is my concave mirror. Pole, say 3 centimeter from here, this is my focus. 3 centimeter from here is my center of curvature. This is my convex mirror. Silvering is this side. Pole, focus, center of curvature. Now the first law which you have to know, children, that is a ray which will come parallel to the principal axis after reflection from the mirror will pass through the focus. After reflection from the mirror, it will pass through focus. Now, what is the equivalent ray for convex mirror? For convex mirror, children, a ray which comes parallel to the principal axis. Now, mind you, children, light will fall on the reflecting surface. Then it will be reflected in such a way, that if you extend this backward with dotted line, it will meet at the focus. So learn the first ray. A ray which comes parallel to the principal axis for concave mirror, after reflection, it will pass through focus. And for convex mirror, a ray which is coming parallel to the principal axis, after reflection, it will go in such a direction that if you extend the line with dotted lines, it will meet at the focus. Now let us go for the second ray diagram. This is my concave mirror. This is my pole. This is my focus. This is my center of curvature. Now for convex mirror, this is my convex mirror. Silvering this side. Pole, focus, center of curvature. Now children, if you remember that for light it has the principle of reversibility. That means if you tell light to go back, it will try to go back along the same path. So from here, if you tell light to go back, so by the principle of reversibility of light, a ray which will come through the focus, a ray, if you tell light to go back, reverse, then it will go back along the same path. That means after reflection, it will go parallel to the principal axis. This comes from the principle of reversibility of light, children. A ray parallel pass through focus and ray through focus will go parallel. Reverse is also true. Now, for this one, what can we say? A ray, reversibility, children. A ray which was coming towards the focus. If the mirror wouldn't have been there, it would have come towards the focus. After reflection, it will go parallel. A ray which was coming towards the focus will go parallel. See the reverse, children. The principle of reversibility. Here the ray was coming parallel. After reflection, it will be, when extended backward, it will go through focus. And here a ray which was coming towards the focus. After reflection, it will go parallel. Now let us go to the third rule for the ray diagram. This is my concave mirror. This is my pole. This is my focus. This is my center of curvature. Now for convex mirror, this is my convex mirror, pole, focus, center of curvature. Now we know, children, for a plane mirror, if you have a plane mirror, a ray which comes normally will be reflected back along the same path. And for a sphere, I told you all, for a sphere, the radius from the center, if you draw any line, it is perpendicular to that point. From the center, if you draw a line to a spherical surface, it is always perpendicular to that point. So a ray through the center of curvature can be taken as normal to the surface. And any ray which falls normal on a mirror will go back. So, if you take a ray of light, coming through the center of curvature, it falls normally, so it will go back normally. A ray through the center of curvature will go back along the same path. Now here, a ray which is coming towards the center of curvature, if the mirror wouldn't have been there, the light would have passed through the point C. A ray which was coming towards the center of curvature will go back because it is a normal ray. Mind you, for convex mirror, children, reflecting surface is this side and light should fall on the reflecting surface. The fourth law, which you should remember, children, for drawing ray diagrams. This is my concave mirror. This is my pole, focus. See, I have measured PF 3 cm, FC 3. You can keep it 4, 5, whatever you want, but the distance PF should be equal to FC. Now, this is my convex mirror, pole, focus, center of curvature. Children, you people always make a mistake, is that for a convex mirror, I don't know, while drawing, you'll draw the center this side. Why? If you complete the sphere, center will be this side and focus will be here. Don't make a mistake. Remember. Now the fourth law which you should remember, children, is if you have an incident ray falling at the pole, if this is my angle of incidence, children, because a line through the center is my normal. I told you this is my normal. And this is my incident ray. This is my incident ray. How will the ray be reflected? Laws of reflection, children, angle I equal to angle R. So you have to measure equal angle with your protector. And these two angles should be equal. Angle I should be equal to angle R. This is my reflected ray. Remember, children, line through the center of curvature is my normal. Now here, will light fall on this side or this side? Light should fall on the reflecting surface. So this is my incident ray. Line through the center of curvature is my normal. This is my normal. This is my incident ray. This is my angle of incidence. Now with equal angle, you have the reflected ray, angle I equal to angle R. Why? Because line through the center of curvature is normal. Children, while drawing ray diagrams, try to follow this number 1 ray, number 2 ray, the third. Try to avoid 4. While drawing your diagrams, try to avoid this 4th ray. Try to complete your diagram with these 3 rays. Why? Because this is also correct. It's not that it is wrong. But the thing is, while doing it, you have to use your protector. And while using a protector, if you make a mistake of 1 or 2 degrees, your image won't be formed at the same point. So try to avoid the 4th ray. Try to finish your diagram with the first 3 rays. So once again, let me revise. These are convenient rays for the construction of image of spherical mirrors. For concave mirror, a ray parallel will pass through focus. Ray through focus will go parallel. That is principle of reversibility of light. And a ray through the center of curvature will go back because it is normal. It falls normally on the mirror. And any ray which is normal will go back. For convex mirror, this side is the reflecting surface. A ray parallel will be reflected in such a way, extended backward, will meet at focus. A ray which was coming towards the focus, after reflection, will go parallel. This to follow the principle of reversibility of light. A ray which falls normally on a mirror, normally means it should be passing through the center of the mirror. Center of curvature of the mirror. A ray which falls normally on the mirror, that is, it was passing through the sea, it will be reflected back. And the last fourth one, this is my incident ray. Through the sea goes my normal, angle I equal to angle R. Here light is falling on the mirror. This is my normal because it is passing to the center of curvature. By the laws of reflection, angle I equal to R. This should be done with a protector.